So I'm here with Matt Genge, a geologist outside the Royal School of Mines at Imperial College London, on a cloudy day here in the heart of London. And Matt has a new paper that's just coming out in Nature Communications tomorrow. And Matt, tell us the gist of the paper.
So we've studied some tiny pieces of rock from Asteroid Ryugu, which is a really carbon and water rich asteroid, the kind of asteroid that probably delivered all the carbon and water for our planet. And in that sample, we discovered evidence for a whole new way of making these types of asteroids, that maybe they're formed not just at great distance, which is what everybody has thought up until now, but perhaps they could be formed where the early solar system was really turbulent and disturbed. And it's in those places that these carbon and water-rich particles are concentrated.
And tell us how that happened.
So the way it happens is that the finest grain dust, really tiny little dust particles, they escape most of the heating, so they keep their carbon and their water. And in turbulence, where we get these really rapidly turning eddies of gas, they throw out the big particles and keep the really fine dust. And then if you make an object like an asteroid there, it's mainly fine grained, so it contains lots of carbon and water.
And you were working with a sample which was only a millimeter in size, correct?
So this is a millimeter sized particle. To me, that's actually a boulder. So I'm used to working on extraterrestrial dust, which is about 10 times smaller. So whereas a lot of my colleagues probably who work on bigger samples thought, oh, this is so tiny, to me, it was almost too much information.
But you don't know what caused the melting of these chondrules, correct?
So chondrule formation, and we call these tiny little droplets that form early in solar system chondrules, nobody actually understands how they form yet, or there are lots and lots of theories, but nobody really agrees. And it's unfortunately a really important part, we think, of how planets form. And it probably occurs across the universe in all those other exoplanetary systems. So it's a bit embarrassing we don't know after 150 years of study, but we're getting there.
And why is this important? Why is the mere fact that these tiny chondrules are melted, why is that important again?
Well, planets are the way they are because of the materials that build them. You know, so the Earth, we have this nice water and carbon bearing planet, which is a good host for life, for creatures like us. So if you make them mainly out of dry materials, no oceans, no life. And when we heat materials, when we heat dust grains, they start losing their low temperature components like water and carbon. So chondrules, when we make chondrules, we are changing their composition, and that changes the planets that you would make from them.
But how is the water actually delivered via these chondrules?
Well, we think that the Earth formed in a part of the solar system, the inner solar system, that was very hot. So it was dry, it was carbon poor. So the idea is that material is delivered later by the collision of these carbon and water rich asteroids.
And what's next in this research?
So what's next is we're continuing to study samples from Asteroid Ryugu. We're also applying to look at samples from Asteroid Bennu, which is very similar to Ryugu, but with some slight differences. And we are looking forward to receiving more samples from space, because there's lots of different planetary missions in the offing that are going to do sample return.
And you were telling me in the interview just now that your favorite idea for what causes the melt of the chondrules itself is shock heating in the disk, in the protostellar disk, or did I hear you wrong?
No, so my favorite mechanism is that shock waves move through the disk, and you probably, if you've ever watched a movie with an explosion in it,
right,
you've seen a shock wave, you've seen that rapidly moving shell that moves away from the explosion. And if that's fast enough, and it hits dust, the dust gets heated by collisions with gas molecules, and it flash heats them to make molten droplets.
And so where are we in terms of sampling asteroids, learning about the earliest formation in the solar system? How far have we come in the last 20 years, and are we halfway to understanding the origins of our own solar system at Earth?
So I think the last 20 years, the really big advances have all been related to sample return missions. So we're finally understanding which asteroids are related to which materials, the materials that fall to Earth naturally as meteorites. So now we've got a really good understanding of where in the solar system these materials come from. But over the next 20 years, we're going to sample more and more unusual asteroids and learn more about the early solar system. Who knows, maybe we will even finally figure out how chondrules are formed.
So Matt, thank you so much. Congratulations on the paper this week, and thank you so much for taking the time to speak to us.
Thanks.